Okay, good morning. Good morning, everyone. Sadiq, Sanmum sir, Subramanian. Okay, so here we are going to continue with our yesterday's discussion. Yesterday we discussed about how to install and configure a single node cluster. Today's discussion, so here we make use of this infrastructure as a service. Okay, so here we make use of this EC2 to create an instance and do the all the needed configuration on top of it. Today's discussion is what are all the services that we can associate with this Hadoop cluster? What are all the AWS services that we can associate with this Hadoop cluster, and what is the way by which it will facilitate more value added when it is associated? Okay, associated with the above set. We can associate auto scaling, we can associate SNS notification. These are all the two services that we can associate with our cluster. So before going into this discussion, you need to have a little bit more. So how the additional workload can be tackled, and what are all the possibilities, or why we need to add some additional nodes, how a name node detect the failure of data nodes. These are all some conceptual understanding that you should have before proceeding further. Okay, so here this big data Hadoop, you are all aware of, it is a master slave architecture under which you have this master name node will take the entire control. What sort of information will name node is maintaining? Name node will maintain metadata information about the entire cluster. Metadata in sense the data about this cluster. So what are all the files that has been stored in Hadoop file systems? Who is the owner of the file? Okay, how many blocks each and every file is occupying? Where the blocks has been stored, like information is stored by the name node. The name node stores those informations of metadata in a file called as fs image and a edit log. These are all the two files which holds the copy of metadata. Where metadata will be managed by the name node will manage these files in its RAM memory. That is the key thing. In its RAM memory only, this fs image and edit log file will be managed. Why it is managing in a RAM memory rather than managing in hard disk? Because all the data nodes, imagine there is a cluster with 100 data nodes. Okay, so we have apart from that name node, we have secondary name node, we have job tracker, and we have multiple task trackers which is used to execute this task. So everyone will connect with this name node for certain informations, because the name node alone will know the metadata information about the cluster. Each and every node will connect with the name node, requesting some information from the name node. So if the name node store all those informations, manages all those informations in its RAM memory, it will be easy for the name node to immediately respond to the request that is it receives from the above set nodes. Instead of that, if each and every time if it want to look into this hard disk, if it manages those informations, metadata informations in the hard disk, each and every time it need to make a read into the hard disk. Whenever there is a updation in the cluster, those metadata need to be returned. So you need to read and you need to write uh, more frequently in hard disk instance. It will be a time consuming. Why so? Because hard disk being electromechanical device, the time taken to perform a read or write in a hard disk is very slow compared to that of reading and writing in a RAM memory. So if hundreds and hundreds of requests is approaching hard disk, then it may result in a overall performance degradation. So that is the reason why it is architected in such a manner that those metadata information it manages in this RAM memory. Okay. So if a name node downs, what happens in the cluster? If a job tracker downs, what happens? If a data node downs, what happens? How we can add additional nodes to the cluster? All these are responsibility of this cloud engineer. Whenever there is a node down, the cloud engineer need to detect that failure, and he need to add additional nodes into the cluster. Then this will be taken care by the Hadoop team. Okay, so the implementation and maintenance of those cluster is the responsibility of the cloud team. So how a name node came to know that the data node got failed? So imagine in this scenario, we will be having let me open with another new. We have the following scenario: name node followed with 5 data nodes. Data node 1, data node 2. Okay, so we have a file 1.txt. Imagine whose size is 192 MB. Here these files will be divided into blocks B1, B2, B3. Yesterday itself I had told you that the default block size here in case of Hadoop is 64 MB block size. Therefore, with an assumption default block size of 64 MB, it is divided into 3 blocks: block B1, B2, and B3, and these blocks will be stored across this cluster. Okay, so it is the responsibility of the name node to decide how to distribute these blocks, which is beyond the scope. What we need to do, just we need to put the file into this HDFS. Then the name node will decide which data node the data need to be written, and how it need to be written will be governed by the name node. Okay, so here it will be assumed that this file has been splitted, and it will be stored across the following manner with the default replica of 3. You know why we need to have a replica? Because the data nodes are being made up of commodity hardware. There may be a commodity hardware. There may be a probability of frequent failures of the data node. If you have stored your data on a single data node, which may result in a data loss. To overcome from this sort of problem, so here it is recommended to go for minimum 3 replica. Each and every block need to have 3 copies. Okay, those 3 copies need to be distributed across all multiple data nodes. It is not all the data nodes, across multiple data nodes in the cluster it will be distributed. Okay, it is the responsibility of the name node to do all those things. We admin, we no need to bother about that. If in case the Hadoop admin team will take care of it. Okay, so here each and every data node, what it will do, so it will send a heartbeat signal to the name node. It will send a heartbeat signal for every 3 seconds once to the name node, each data node. If a name node doesn't receive a heartbeat signal continuously for 10 minutes, then it from a particular data node, it assumes that the data node is dead. So if it doesn't receive a heartbeat continuously for 10 minutes from a data node, it assumes that the data node is not live. Once it fixes a data node as a dead node, what action the name node will initiate here is, so here, now what we need to do, okay, imagine this data node is assumed to be failed. Data node DN2 is assumed to be failed. So here the blocks that has been stored, the block B1, initially it was stored in data node 1, data node 2, and data node 3. Similarly, block B2 was initially stored in data node 1, data node 2, and data node 3. Okay. So in this case, if this data node 2 fails, here these 2 blocks will become inaccessible. Okay, now B1 and B2 will become inaccessible. So in this case, instead of having 3 replicas, now this block B1 and block B2 now is said to be having only 2 replicas, which is against the default replica of 3. This is called as a block under replication. Block under replication. So it is not at all a good solution to have two copies of a block. So if a data node fails, then it may result in a loss of information. So what the admin need to do, cloud engineer? Sorry. You want to observe continuously which data node is live, which data node is dead. If you found that data node is dead, that data node need to be replaced. Okay, how that, and there will be a alert sent by the name node. Okay, the name node for every 3 seconds once the data node send a heartbeat signal to the name node. If a name node doesn't receive a signal for continuously 10 minutes, it will notify the failure of the data node. It can be captured in a screen, URL screen. Okay, browser screen by using a particular URL which let us know what is happening inside the cluster. So once we find that the dead node, you want to initiate this action to add the additional node into the cluster. Okay, the process of adding or removing a node into the cluster, we call it as commissioning and decommissioning of data nodes. Commissioning and decommissioning of data nodes. Commissioning in sense adding a new data node, decommissioning in sense removing an existing data node from a cluster. It may be due to for its failure, or it may be due to some maintenance related activity. We may do frequently adding or removing the data node into the existing cluster. Okay, so whenever a name node detect the particular data node got failed, it will look into the metadata. The metadata will contain the following information. This information is present in FS image file. The state of the cluster, the original metadata will be present in the FS image file. So in this case, what happens here is, so here we have block B1 and block 2 is said to be under replicated block because of failure of data node DN2. Because of failure of data node DN2, we can't able to access the blocks B1 and B2. So the name node at any point of time need to maintain a 3 replica at any point of time. So it will initiate an action. It will look for other data nodes which is holding the same copy. Now you have the copy of block B1 is present in both DN1 and DN3. It will, the name node will indicate instruct any one of the node. Example, let me take it is data node DN1. Data node DN1, you have block B1, you copy the block B1 into the location. What are all the options? Now we have options data node DN3, data node DN4 and data node DN5. Okay, so which data node it will be copied? Can we copy to data node DN3? No. Also because since it is already having a block copy B1, you can't have more than one copy of a same block. So that is mandatory. So each data node can hold only one copy of a block. You can't have two copies of a block. Therefore, this is not possible. Then the option is either data node DN4 or data node DN5. These are all only the two options. Okay. So now the block B1 will be instructed to copy on data node DN4 or data node DN5. Okay. Accordingly, let me imagine it is copied on data node DN4. Now this information of block B1 because of failure of data node DN1, now it is copied in data node DN4 and we have the previous copy in the following location. This change in this cluster is recorded in the following file, edit log file. This change in the cluster. This is the original status of the cluster. The change, what are all the change that we made in the cluster is recorded in the edit log file. Please make a note. Okay. So now we have two different data for a block B1. Similarly, for block B2, it will initiate this activity. Now this under replicated block now will become 3 copies. Automatically, the default copy is set to be maintained here. Imagine a situation. So if this failed data nodes is recovered back and if it is added back to the cluster, now what happens in this case? Now we have 4 copies. Instead of 3 copies, we have 4 copies. That is also not recommended. Also because it occupies more storage space. If you do any updation, all these things need to be reflected in all the blocks like thing. Therefore, it will be a overhead. Adding a new copy or the copy is lagging in its default, both the thing is not recommended. If you have 4 copies in this scenario, then we call this block as over replicated block. Over replicated blocks. Under replicated blocks and over replicated blocks are two causes which the administrator need to resolve. So you no need to bother about that. If you add a data node after its recovery, once if a name node detects that we have 4 copies of the block, it will remove the copy from any one of the data node automatically. Okay, you no need to remove as an administrator. So the thing will be taken care by the Hadoop framework, the name node itself. Okay. So here in this case, the FS image and edit log is said to be having different information. This problem is called as data inconsistency problem. So is it clear for you? Please, all the things that we are referring is for our role of commissioning and decommissioning, how to commission and how to decommissioning the data nodes. For that, we need to go through across this basic concept. Okay, please, if you can't able to understand, please let me know. I will. Now we are going to discuss about this block over replication. So now if we have this block B1 first copy here, we have first copy here. We have the second copy of the block in data node DN3. We have the newly copied block B1 in data node DN4. So now you have 3 copy, no issue. If this failed data node got recovered, so the data node which is initially failed, assume that it is recovered back. What happened if it is recovered back? This data node itself is having a block, is it? Now the data node, if it is recovered and added to the cluster, now we have instead of 3 copies, we have 4 copies. Okay, we have this fourth copy. This additional copy is called as over replicated block. Over replication is also a problem. Okay, so automatically the name node will initiate the action. It will remove any one block. It based upon its rack awareness. And it will retain the default 3 copies. Okay. Here, how this the under replication problem will be solved. Okay, now we have these 2 files. FS image and edit log. Now we have 2 files. FS image and edit log managed by the RAM memory of your name node. Okay, name nodes RAM memory it is managed. Here, each file contains different information. One file is saying that data is having at data node DN2, data node DN3. Yes, this is correct. Data node DN2 and data node DN3. But instead of data node DN1, it is recorded as data node DN4. The same block is said to be occupied in 2 different data nodes. It may lead to confusion. This problem is resolved by the secondary name node. Secondary name node, what it will do here is, it will take this FS image and it will take this edit log. It will fetch both information and it will synchronize the content of edit log. What are all the content present in edit log? It will read the content and it will update the FS image. So once the FS image is updated, this updated FS image will be replacing the old FS image. Okay, it will replace. Now we have new FS image. So the new FS image, once the new FS image has been copied, it will reset the edit log. It will clear all the contents of the edit log, and edit log will fail also will have a new edit log. So the updated FS image, it will store in its hard disk for later usage. This thing happens for every 1 hour once by default. If you want to make it happen every 10 minutes once, this is the responsibility of the administrator to decide the timing of this particular action. This particular action of taking the FS image and edit log and synchronizing the content of edit log and FS image to create a new FS image and taking the backup of this new FS image in its hard disk for later usage and replacing the new FS image by the old FS with the old FS image on the name node's RAM memory. This process is called as a checkpoint. This is an interview question. Checkpointing. For this activity only, we need to configure a secondary name. For this activity, you need to configure a secondary name. Now is it clear the role of secondary name node? It may happen by default every 1 hour once. We can configure to make it happen as per as our requirement. Okay. Now you know the concept behind the name node and secondary name node, and data node's responsibility is used to store the data. These are all the ways by which you can able to identify the failures of data node, and the action a name node will initiate because of data node failures and the functions of secondary name node. Okay. Now we are going to discuss about how to configure the same thing using this elastic MapReduce, our service. EMR stands for elastic MapReduce. The CMR is a Hadoop distribution of Amazon. Amazon's Hadoop distribution. What do you mean by distribution? You people are aware Linux is a open source. You can download this open source. No, reducing checkpoint won't lead to performance degradation. Okay, if a checkpoint reduce your checkpoint, if you have a lot of frequent updations in your cluster, then if the checkpoint happens, example, you have name node, you have secondary name node. So the checkpoint even is assumed to be happened at a 10 a.m. instance. Now the secondary name node will have a backup copy of 10 a.m. So the next checkpoint will happen only at 11 a.m. instance. If intermediately at 10:50, if this cluster got down, if the name node got down, and in the meantime of 50 minutes, we may have lot of updations if in the cluster, and we have lot of information present in edit log. So if a name node got down, what happens to this? The edit log and FS image, being it is maintained in the RAM memory, RAM being volatile memory, both the file will be lost. But we have only the updated information only taken back at 10 a.m. So all the updates in between 10 to 10:50 will be lost if we have a larger time interval. So during the recovery of the name node, secondary name node, what it will do, it will help the name node by copying the backup into the RAM memory. So the name node will look into the data and it will know the status of the cluster at the time of its failure. So which backup copy that we are having? The backup copy last we have taken at 10 a.m. But what happened to the name node? The name node functioned up to 10:50, and there may be lot of updations. Those updations will be lost. That is the problem associated with having a longer duration of checkpoint interval. In this case, if you imagine the checkpoint time duration is 15 minutes, instead of 1 hour by default, we have configured to do this activity every 15 minutes. In sense, what happened? We have taken a backup at 10:15, 10:30, and 10:45. Now the time is 10:50. At the time of 10:50, if a name note down, now we have backup copy up to 10:45. What activity that happened? What are all the updates that happened in last 5 minutes alone will be lost here in this case. That is the advantage in going up with reducing the number of frequency of this checkpoint activity. But if a checkpoint activity performs, definitely there will be a little bit slowdown in the cluster, which is not having a great impact. Which is because all our data storage and data processing will take place only on the data node only. So not on the name node. The name node is the master node. The name node will control all the things. Every process will be done only on the data node only, as I already told. Okay, if you want to store data, if you want to process data, that thing will be taken care by the data node, not by the master. So the master, the checkpoint activity will be taken care by the master nodes, name node and secondary name node only. So it won't have a much influence in its performance. Okay. So we need to configure this checkpoint time in a file called hadoop-environment.sh. We will have a discussion. Okay. Hadoop-environment.sh. Checkpoint admin. The Hadoop admin will take care of. The parameters associated with the Hadoop will be handled. For our the action that need to be taken care by the cloud admin is to launch the cluster and monitor the cluster and to notify the Hadoop admin the changes that is happening on the cluster. If there is a node down, those things will be monitored and you need to up the node again. These are all the activities. The Hadoop related activity like doing the modification, everything will be taken care by the Hadoop admin. But you need to know what is happening in the backend. That is the reason why I am handling all those things. Okay. So these are all the ways by which the secondary name node will help the name node in its recovery phase. Now let me discuss the concept of elastic MapReduce. What is distribution? So we have a Linux. It is a open source. We can download the software, operating system software, and you can add some features on top of it, and you can release under your own name. By the way, we have Red Hat Linux, we have Ubuntu, we have Cent. These are all called Linux distributions. Okay, all the thing will have 80 to 85% in common. What we have in the open source code. On top of it, 10 to 15% they have added some new features. On top of it to facilitate the easy user interaction and easy management, and they have released under their own name. So you can, if you need a support, you can't use this open source Linux in your server. Imagine you are having a database server in your company. If you are using a open source Linux, you no need to pay anything, but you should have a team which should be able to handle these issues associated with these servers. You can't get a support for open source. But if you purchase a Red Hat, for using Red Hat, you may not need to pay. For using Ubuntu, you may not need to pay. But if you want to get a support, you need to have a agreement with this corresponding corporation, Red Hat or Ubuntu or Cent. You need to go for yeah agreement. Either it may be a golden, or it may be a platinum plan, or it may be a silver plan, like everything. Okay, according to the type of support need, you need to get a support. Okay, so for that you need to pay for. Similarly, so here Hadoop was developed by Apache Open Source Foundation. Apache Open Source Foundation. So from Apache Open Source Foundation, several corporations are downloaded and they have their own release. Those releases is called Hadoop releases. Out of which Cloudera Hadoop is the leader. Hortonworks is the follower of Cloudera, the second Hortonworks. And we have Mapr and we have EMR, Elastic MapReduce, which is AWS distribution. Okay, so these are all the prominently used distributions. Now we are going to focus our discussion on this EMR, Elastic MapReduce. Let me connect with this AWS to have a direct. This is EMR, Elastic MapReduce. It is organized under the analytics. Click on EMR. So here you no need to configure each and everything. Everything will be configured here. In Elastic MapReduce, everything will be configured. Okay. So what you need to specify? You need to specify only two things here. How many data nodes? The second thing, the hardware details. That is your instance details. For your master and for your the slave data node. That alone you need to specify. Then a cluster will be formed according to, if you specify number of data nodes to be of 3 and I need a micro instance or a small, minimum we can take only a small instance or a large instance. The option is a small or large instance, that alone minimum we can take. So here accordingly a cluster will be formed, Hadoop cluster will be formed. Here you no need to install anything. Everything starting from Java, SSKites, Hadoop, everything will be configured by default. Here, how we can make use of, imagine that you have 3 data nodes. Each data node, okay, you have 3 data nodes. Each data node is assumed to be having 2 terabytes, 2 terabytes each. Therefore, you can able to store 2 terabytes of data here. If your data size increases, you have configured this cluster and you are going to do some sentiment analytics. Let me imagine you are going to do some sentiment analytics by crawling data from the social networking site. Okay, like Facebook or Twitter like thing. You are going to do a sentiment analytics whether the ADMK government will survey or not. What people are thinking. If the government, whether they will vote for the government or not according to the current situation. Each and everyone may have a recordings, what they are thinking of. They may posted what they wish to communicate through the social networking sites. We want to do sentiment analytics by taking the data and to do process on top of a Hadoop cluster. In this case, you can't able to predict how much of workload that you will receive here. So we have a 3-node cluster with the assumption that we crawl 2 TB of data. If the amount of data is more, imagine if it is 4 TB. In this case, how many data nodes that we need to have? 4 into 3. So 12 TB need to be stored. Therefore, a single data node 2 TB instance, we need to have 6 data nodes. So whether we need to have all the 6 data nodes initially, the answer is no. Why so? Because initially the crawling will occupy only 1 TB. Slowly the informations will be retrieved. So if we initially with anticipation that if we have initially 6 data nodes and all the data nodes, imagine if it is a large data node, you need to pay more for the cluster. So you need to attach the data node accordingly to your workload. Whenever a necessity arises, in these circumstances only, you need to add additional data nodes, go and add to the cluster. You can do two the activity. One, you can debut a human to monitor this. What is the current workload incoming load to the cluster? Else what you can do? You can invoke a alarm using CloudWatch. you can create an alarm using CloudWatch, and the alarm may initiate a auto scaling action. So what you need? You need to have this service of CloudWatch and auto scaling need to be integrated. So if you want to notify a event, you can here attach this SNS notification services. Why you need a notification? When you add a node or when a node is removed, it need to be informed to the concerned administrator. So he is the guy who is going to maintain the number of nodes that is running on the cluster. Also because accordingly only you need to make a verification of the billing statement. So this information need to be notified to the concerned administrator. So we have this SNS. Now here comes this, if you integrate this auto scaling with this Amazon EMR, what happened here in this case? This activity according to the workload, you need to write a script in such a manner that if the CPU utilization of our cluster, this is your EMR, this is your elastic MapReduce EMR cluster. Okay, it is assumed to be having 3 nodes. Here if you attach this auto scaling, the auto scaling is said to be having reserved 3 instance. So here if a CloudWatch, you will invoke this CloudWatch to monitor for either a CPU utilization, either a incoming traffic, those sort of matrices can be monitored. Example, the CPU utilization, that is the average CPU utilization of 3 data nodes. If it is greater than 95%, what it is indicating? It is fully occupied, that all the 3 data nodes is processing fully. Therefore, we are instructed to add a new data node. So here, once this condition has been satisfied, this condition has been set by the CloudWatch alarm. In the alarm, we want to set the condition. Once the condition reaches the threshold, what happens is a new node from the auto scaling group will be attached to the cluster. So once a new node will be attached and all the data will be evenly, cluster will be rebalanced, the rebalancing activity. So if all the 3 nodes are fully populated and a newly added node, if it does not contain any information, that is not a good thing. Therefore, the data that is shared by the load that is shared by 3 cluster now need to be distributed across this 4th cluster. Okay, so a new node is added to the cluster. At that time, being the distribution is happening, it may affect the performance here. You please make a note. The performance may be little bit degraded if you add a new node. Okay, at the time of redistribution of the workload. So similarly, if this condition satisfies, you may have another condition. This is a condition for scale up. You may write another condition for scale down. The scale down, if average CPU utilization is less than 40%. That means imagine you have 2 nodes. Each node is occupying only 40% instance. Total workload is 80%. You no need a two node. Using a single node itself, you can make use of this 80% load can be utilized here using a single node itself. So this is the script for scale down. If the average CPU utilization less than 40%, you instructed to remove a node. Which data node need to be removed will be taken care by the master. We no need to specify that. So once a data node has been removed, the load will be again need to be redistributed. What are all the data present in the data node want to be redistributed with the remaining 3 data nodes. So if you add or if you remove a data node, being you need to go for load distribution across this current node in the cluster, which may affect your performance. Also because the data node is responsible for data storage and data processing, so it may result in a slow processing of data during this activity. Okay, please make a note. These are all the way by which if you face the cluster performance is degrading, if a client is complaining that the cluster is slow, then the activity of adding or removing a data node may happen. This is one reason. It is not a primary reason, it is one reason. Okay, by the way of attaching auto scaling with VMR and the CloudWatch. Once a node is removed or once a node is added, you can invoke this SNS notification to do the thing. You can invoke a SNS to notify the concerned administrators. Now you can find a create cluster. You no need to do anything. The name of the cluster. So it may be Sadik. Okay, if you want to log any information, what is happening in the cluster, so you can enable the logging. What are all the thing that is happening will be stored in the S3. You want to create a S3 folder, and the folder will record the log. Okay, so here they have a folder S3. Once you click, what are all the folders associated with your account will be listed, and you can select the folder to make a log. Okay, so S3. Then launch mode. There are two ways by which you can launch this EMR. One is either the cluster alone will be launched. The step mode, it will set a specific set of activity that we need to go for. In this step execution, it will specify what release want to do and what are all the associated instance. Everything you need to specify here in a step. Okay, so here if you are going to run a particular job, you want to specify the job, whether it is a Hive job, whether it is a pig job, whether it is a Java custom job, whether it is a Spark. These are all applications associated with the Hadoop. You want to specify here itself. So you are not interested in step execution. First you want to create a cluster. In sense you want to choose this cluster. Then it prompts you for releases. This is the current release. You may have a option of choosing any releases. So this release will contain all the opposite components. As I already told in our Hadoop, Hadoop is not a single entity. It is a combination of several entities. Here you can find a Hadoop along with Ganglia, which is a monitoring tool. So Hive and Pig are data processing tool. Again, Test is a framework similar to MapReduce for processing. Apache Mahout is used for machine learning. For each and every component will do certain activities. So according to this version or what are all the applications that you are interested. For example, if you are interested with the HBase, then you need to go up with this option. If you choose this option, then it will be storing your data in your HDFS, Hive distributed file system. If you want to have a separate database, you need to go. Okay. So hardware configuration. What we are specifying whether it is a cluster mode or step execution. We want to choose what are all the applications that it need to be pre-configured. You will no need to configure by yourself. It will be pre-configured. You need to specify the hardware configuration. What type of instance? If it is a large. Here you want to specify number of instance. For example, one master and one node instance, you need to specify minimum. Automatically, one is assigned to master, one is core. You need to specify the key path. What is the associated key path? And you need to specify the permission. What are all the roles the user of the particular cluster need to be assigned? Here you can make a default role. Here there are three default roles. So two roles, EMR default role and EMR EC2 default role. Then that is the thing that you need to specify. Once you click on this create cluster, a cluster will be created. After a cluster will be created, how to add these steps, how to specify a Hive program, how to write a script, and here what we are going to do. So we are going to do a practice by using a sample script given by Amazon itself. They have a cloud trial logs. This cloud trial logs will hold the information if the user is all the user accessing these AWS services. Those information has been logged from where they are accessing, what is the operating system in the machine, like at the time and date of accessing. So all certain information has been recorded in the cloud trial logs. For example, so this is your data center. I am accessing from my Windows 10 machine. Sadiq may access from Windows 8 machine. Subramanian may access from a Linux machine. Each and every guy may have access to the Amazon data center and they do the activity through a client interface. Those logs will be recorded here in sense. what we are going to do, we are going to write a Hive script. A Hive is similar to SQL. So this script will do the analytics. So out of this given log, a log file is a semi-structured data. Okay, the log file, out of this log file, they want to identify which operating system is used most by the particular user. Okay, for example, the traffic is coming from India. Which operating system is mainly used in India? If the traffic is coming from Sri Lanka, which operating system is widely used by peoples of Sri Lanka? This is the analytics that we need to do. Okay, you want to write a Hive script, and this Hive script need to be stored in a S3. This is your input, and once the process, the output also need to be stored in S3. And if you have configured logs, logs will be stored in S3. Therefore, we will be using S3 for our activity for specifying the input file. The log file, that is the cloud trial log file, need to be specified under a S3 folder of as an input, and from that the log file will be taken by the cluster, and the cluster will do the needed process on top of it according to the script that you have written, and the processed output will be stored in a specified S3 folder. Okay, you can once the activity has been over, you can look into this S3 folder to find out the final result. So this is the way by which you can do a action associated with a particular activity. So here if you click create the cluster, it took minimum 10 minutes to create, 5 to 10 minutes to create and configure each and everything. And after that, writing a script and all the associated things, how auto scaling can be integrated, how a SNS can be integrated, will be discussed on tomorrow. Okay, is it clear? The today's session we have discussed about the concept behind this Hadoop cluster. So here the implementation will need only 10-15 minutes for our creation of cluster, and to specify a script it will need another 15 minutes. And we will discuss how to integrate for along with the cluster, how to integrate auto scaling, how to integrate SNS will be discussed on tomorrow. Okay, it is almost time 7:45, 7:50. So thanks a lot. We can meet again on tomorrow. Same link, the same link for the entire session for next 20 days. You can use the same link. No need to go for a new link. Please make a note.